Hello, welcome to the lecture course CH-102 Organic Chemistry for F.Y.B.Sc class. In previous lecture we have discussed the different factors that affect the stability of conformation of cyclic compounds. So in this lecture we are going to discuss about the conformation of cyclohexane. Conformation of cyclohexane. Conformation of cyclohexane. So, such a scientist in 1890 suggested that the cyclohexane molecule, that is C6H12 cyclohexane molecule, exists in two non-planar structures. Which will be free from angle strain. That is the first is the chair form, and second is the board form. So when you draw the chair form, we have to draw two parallel lines, but like this. You have to draw parallel lines like this. Okay, and these parallel lines equal in length, but we draw like this here. So we connect like this here. So this is the first chair form. Second, we can draw in opposite way. We have to draw this kind of two parallel lines, and we have to join like this. So this two chair form we write here 1, 2, 3, 4, 5 and 6 carbon. 1, 2, 3, 4, 5 and 6 carbon. Okay. So in the chair form we can observe that carbon number C1 or carbon number 4. C1 is above the plane, while C4 is below the plane, while carbon number C2, C3, C5 and C6, they are present in one plane or they are present in average plane. For this structure, we can write here that the C4 is above the plane, C1 is below the plane, while that is the carbon number 5, 6, then C2, C3, all these carbon present in one plane, that is average plane. What we can say? Average plane. So in this way we can draw the chair conformation. So these two chair conformation, that is we can name suppose C1 and C2, they are equivalent. They are not different, they are equivalent. So they are interconverted into one another by carbon-carbon single bond rotation here. So they are called as conformation isomers. Next is the board form. So board form, chair form is converted into board form. That time we can write the two board form here like this. Also we write here second board form. Okay, like this. So board form 1, 2, 3, 4, 5 and 6. Carbon number 2, carbon number 3, carbon number 5, carbon number 6. They are present in one plane. Okay. and carbon number 1 and carbon number 4 is above the plane here in first structure. But they may be above, they may be below the plane. Here 1, 2, 3, 4, 5, 6. Here carbon number 1, carbon number 4, they both are below the plane. They are below the plane. And remaining carbon, carbon number 5, carbon number 6, carbon number 2, and carbon number 3. They are in one plane. They are in one plane. So, first form, second form, both form, they are equivalent. We can call B1, B2. They are equivalent. They are not different here. And this both form can be interconverted to each other by carbon-carbon single bond rotation. So chair and both form, they are interconverted. They are conformation isomers of cyclohexane. In conformation of cyclohexane, chair and both form are interconvertible by carbon-carbon single bond rotation. So they are conformation isomers of cyclohexanes. So how they are interconvertible here? So firstly, if you consider the first chair form like this, you can draw like this chair form. Okay. So in this first chair form, if you give the numbering 1, 2, 3, 4, 5 and 6. Okay. So here carbon number 1, carbon number 4. Suppose if you rotate along C3 and C4 bond, so we get the both form. So we get the both form like this. So after this rotation along this, what happens? The carbon number 4 come at this position, then 4, then 5, 6, 1, 2, 3 like this. So here this 5, 6, 3, 2. In both form they are coming one plane, and 4 and 1 they above the plane. So like this. Secondly, if you rotate at this position, at A position, if you rotate this bond, okay, that time we get the second both form like this. We get the second both form so that second both form, in that we can observe that 1 come at this position, 4 carbon, 2, 3, 4, 5 and 6. So carbon 1 coming at this position. So this 1 and 4 is below the plane here. So we get the second both form here. So B2. We can call to this B2 and this to the B1. Okay? Like this. So this both form again we can convert into by along this bond into chair form. So after rotation, carbon number 4 come at this position, then 5, 6, 1, 2 and 3 like this. So we get this kind of both form. So the chair conformation. So if you rotate along this bond, that time we get this kind of chair form. And after this rotation, so suppose if you rotate along this bond, we get the chair conformation like this. So 1, 2, 3, 4, 5 and 6 like this. So along along this rotation, both form convert into chair form. Along this rotation, along this carbon, we get the again chair form, and these two chair forms are equivalent here. So like this. So in this way we can say that chair and both forms are interconvertible. They are called the conformation isomers of cyclohexane. In this way we can show the interconversion of chair and both conformation of cyclohexane. So next point, that is the axial and equatorial bonds in cyclohexane. Axial and equatorial bonds in cyclohexane. So, molecular form of cyclohexane is CH-102. There are 12 hydrogens, so each carbon carries the 2 hydrogens. So all hydrogens are not equivalent here. 6 are out of 12, 6 are axial and 6 are equatorial. And each carbon carries the 2 hydrogen out of 2. One is the axial and one is the equatorial. In this way, we can say that all 12 hydrogens are not equivalent. 6 are axial, 6 are equatorial. So firstly, axial bonds in cyclohexane. So this 6 axial bond we can draw like this. Okay. In this way, we can draw the 6 axial hydrogens or bonds. So these 6 axial hydrogen, they are perpendicular to average plane of the ring and parallel to axis, center of axis passing through the molecule, parallel. Okay. And if you observe this all bonds here, that time we can observe that out of 6 bonds, 3 are above the plane here. So this is above the plane, this is above the plane, this is above the plane. So 3 are above the plane and 3 are below the plane. These 3 are below the plane. 3 are above and 3 are below. So this is the one, suppose 2, 3, 4, 5 and 6. If you number like this, so carbon number carry 1, the axial hydrogen is above the plane, carbon number 2 carry which the axial hydrogen is below the plane. 3 is above the plane, 4 is the below the plane, 5 is above the plane, 6 is the below the plane. Means axial hydrogen is above and below the planes alternatively here. Okay. So this is about the axial hydrogens or bonds present in cyclohexane. When you talk about the equatorial hydrogens, equatorial bonds. Okay. So here so these are the 6 equatorial bonds. In these 6 equatorial bonds, we can observe that this is the projecting outwards, and this 6 equatorial bond projecting outwards and parallel to average plane of the ring. So here, same way we can say that here 3 axials, so 3 equatorial bond is above the plane, 3 are below the plane. So 3, this is above the plane, this is above the plane, and this is above the plane. This is the below the plane, this is the below the plane, and this is the below the plane. So 3 are below and 3 above plane. And we can observe that this is above, this is below. This is up below, so above, this is below. This is above, this is below, like that. Means above and below the plane bond actually present in alternatively here. Here also we can observe that when you write the overall combination of these two structures, each carbon carries the axial bond and equatorial bonds. Axial bond, equatorial bond. Axial bond, equatorial bond, like this. Axial bond, equatorial bonds. Axial bond, equatorial bonds. Each carbon carries. So what we observe from this, so when you combine axial and equatorial bonds in cyclohexanes, means overall if we write the 12 hydrogen, in that we can observe that axial, equatorial. Axial, sorry, equatorial, axial. So to each carbon, when axial bond is above the plane, at the same time equatorial bond is below the plane. See here, over this carbon, suppose carbon number 1, over this carbon, axial hydrogen is above the plane, equatorial hydrogen is below the plane, and vice versa. Vice versa means here, when you observe for next carbon, carbon number 2, this is above the plane. Means equatorial bond is above the plane, axial bond is below the plane. Means alternatively we can observe this. So at each carbon we can observe that axial bond above, equatorial bond is below. For next carbon we can observe that equatorial bond above, axial bond below. So this thing we can observe in axial and equatorial bond in cyclohexane. Also remember that this axial bond, if you give the number 1, 2, 3, 4, 5 and 6 suppose, the axial bonds, so equatorial bond is always parallel to next or previous carbon-carbon bond. So here, if we consider the equatorial bonds, equatorial bond at C2 carbon, equatorial bond. Okay. So C2 equatorial hydrogen or bond at C2 carbon. Okay. This is parallel to C1 C6 bond. Okay, parallel. Also parallel to C3 C4 bond. In parallel to both bonds. See here. Means this bond, this equatorial bond is parallel to next means C3 and C4 bond, and also parallel to previous means C1 C6 bond. So parallel to this bond and parallel to this bond. Parallel to previous and parallel to next bond. So in this way we can always say that the equatorial bond is parallel to previous and next bond in cyclohexane. So in this lecture we have discussed about the chair and board form, how they are interconverted by carbon-carbon single bond rotation. They are conformation isomers of cyclohexane. You know that very well. Also, we have discussed equatorial and axial bond, how to draw axial bond, how to draw equatorial bonds. Now, what is the general characteristics of axial and equatorial bonds in cyclohexane? So in next lecture we will discuss about the ring flipping in cyclohexane. So when ring is flipped, that time what happened regarding axial and equatorial bond we are going to discuss in next lecture. Also we are going to compare chair and board form. Chair and board form we are going to compare in next lecture. Okay, thank you.